In section 1.2, we're going to look at the properties of real numbers. What we're going to focus on today is how the set of real numbers can be categorized into different subsets and how they're related to each other. So here we can see kind of how all the real numbers are categorized into different subsets. We'll go over this a little bit more in class, but what I'm going to want us to focus on today in this video is the difference between rational numbers and irrational numbers. So rational numbers versus irrational numbers. A rational number is all numbers that can be written as a quotient of integers, a over b, given that b does not equal 0. So an example of that could be 2/3, -5 over 4, 6 over 1, and any other example like that. Other examples of real numbers are terminating decimals and repeating decimals. A terminating decimal would be a decimal that has a definitive end, such as 6.1 or 2.5. And a repeating decimal is a decimal that's not necessarily ending, but it has the same pattern that's going to go on forever. So something like 0.3333 that goes on forever. On the other hand, irrational numbers are decimals that neither terminate or repeat, and on top of that, they cannot be written as a quotient of integers. So common examples of these is radicals like the square root of 2, the square root of 17. Another common irrational number that you've seen before is pi. So in problem number 3, we're going to talk about ordering real numbers. So whether you're given a fraction, a decimal, a radical, we want to be able to compare their actual value to one another. So here we're comparing the square root of 17 and 3.8. So what I'm going to want to do is get the square root of 17 to a decimal, so they're kind of the same, in like the same notation, and we can compare them from there. So in my calculator, I'm going to calculate the square root of 17. I'm going to see that as a decimal, it's an irrational number, it goes on forever. It's 4.123 and goes on. But the main thing that I could see is that 4.123 is going to be greater than 3.8. So I can conclude that the square root of 17 is greater than 3.8. Lastly, we're going to look at the properties of real numbers. So within the set of real numbers, there's certain properties that apply to them that will always hold true. The first property that we're going to look at is the closure property. So given real numbers a and b, if I add them together, their sum will also be a real number. Similarly, if I multiply real numbers a and b together, their product will also be a real number. The next property that we have is commutative. So given the real numbers a and b, a plus b will be the same thing as b plus a. Same thing if I do it with multiplication. The associative property shows that given real numbers a, b, and c, the quantity a plus b plus c would be the same thing as a plus the quantity b plus c, and the same thing goes with multiplication. The identity property states that for addition, if I take real number a plus 0, I will still get a. For multiplication, if I multiply a real number a times 1, I will still get a. Next, we have the inverse property. If I add a real number and its opposite together, I'll get 0. Similarly, if I multiply a real number by its reciprocal, I'll get 1. And then last, we have the distributive property, which kind of combines addition and multiplication. If I multiply real number a by the quantity b plus c, that's going to always equal ab plus ac. So a problem that we're going to look at tomorrow and that you might see on a quiz is you're going to look at an algebraic equation and determine what property of real numbers that's showing. So in problem number 4, they're asking which property does the equation -2 over 3 times -3 over 2 equals 1 illustrate. I see that I'm taking this real number and I'm multiplying it by its reciprocal to give me 1. So therefore, I can determine that we are using the inverse property, specifically the inverse property of multiplication.